do this for the 4 sessions.
Okay.
All right. So I'm just gonna. So now it's 1:06. So I'm just gonna start. If that's okay with you.
It is.
All right. So welcome everyone. So I see some faculty members here, some students, to the 4-day OpenSesame workshop. So we are going to do a workshop on experimental psychology using this specific application with the developer himself. So Sebastian Matteau is here. And some of you have met Sebastian before because I have invited him to talk about pupillometry a couple of months ago. And most of you here, I think, have also followed the demo session of OpenSesame that we did together in February. So now I see that you're still interested. So now we're going to follow a series of workshops in which we're going to build an experiment, your own experiment, depending on what do you want to study, the type of research do you want to do. And to guide us is Sebastian Matteau. I have introduced him before, but for those of you who haven't known him, Sebastian is an assistant professor at the Experimental Psychology Department at University of Groningen in the Netherlands. And he's an experimental psychologist. He studied pupillometry most of the time, but he's also developing this very useful and very friendly application that allow other researchers to build their own experiments, namely the OpenSesame software. So what we're going to do in this 4 days, 4 intensive days. So this is the first day. There's going to be 3 more sessions in the 20th, the 21st, and the 27th of April. Sebastian has made the program available on the OpenSesame website, which is very cool. So you can check it out there anytime you want. Just most of the time, Sebastian will facilitate the workshop. I'll always be here to help you. And if I can, I'm also working from the campus. Today, I'm planning to work from the campus, but rooftop and floods and so on. So sorry for that. So yeah, I'm just going to hand the screen to Sebastian. And thank you, everyone.
All right, well, thanks for the introduction, Vishnu. And indeed, so there's no further need to introduce myself, I think. My name is Sebastian Matteau. And let's get started with this first day of the workshop. I do want to have some round of introduction. I think that we're a little bit too many to actually really go one by one. It's a bit, but I have a little Mentimeter just to get some idea of who's in the audience. But actually, as Vishnu already said, I'm currently working as an assistant professor at the University of Groningen. I'm originally actually from Amsterdam, from the Netherlands. So I am Dutch. And that's where I grew up. That's actually where I also went to university and did my PhD at the VU University in Amsterdam. Then for quite some time, I lived in France, in Marseille, where I did my postdoc. And after my postdoc, that's when I eventually landed in Groningen and in the Netherlands. So, and my research is indeed visual perception, eye movements, pupillometry, and I gave a talk also here at Venus University some time ago about that. And an important part of my research is also development of scientific software, and the primary program, the most used program for that is OpenSesame. So the tool that we're going to learn during this workshop. So as I said, I think it would be interesting for me and hopefully for you to get some idea of what the audience is like. And also some idea of what you would like to see actually in this workshop. So I created a very short Mentimeter poll. So the way that works, if you're not familiar with it, is you just go to menti.com, you type in this code 2094008, and then you will be asked first what your position is, so that I have some idea of whether the audience consists of PhD students, staff members, etc. I already kind of know because I just asked it. And then what kind of you want to get out of this workshop? What do you want to learn? So I will give you a minute to actually really engage with this. You can also just do it on your phone. And then, right, let me actually, the head of the lab is here. Very good.
Well, it's just me.
Oh, that's just you. Right. It's not just you, it is you. Up, let me actually get the, there we are. Okay, I'll give it a few more minutes because we have 16 participants and I see 4 responses at this moment. Okay, a very mixed crowd, clearly. And Vishnu is pointing out in the chat that there is an attendance list for everyone to fill out. Okay. And then if we go actually to the next slide, you will see, so I have some idea now of what the positions are. Faculty member, PhD student, lecturers, quite mixed. If you go to the next slide, you will see that there's the question, what do you want to learn? I really want to know what I can do with OpenSesame so I can use it for my own experiment. But right now I'm in the middle of a crisis about my research interest, so I can't decide what I am actually going to do just yet. That's okay. So one important goal of this workshop will be to indeed develop your own experiment. But we also have a few suggestions. The main reason to have people work on their own experiment is also because that is a very sort of more engaged way to do that, if you see what I mean. So it's more, you will engage with the software better and learn it better if you work on something that you control yourself, as opposed to when you're just following along what I tell you. How to use OpenSesame app, because this app is new to me, to master OpenSesame so I could make great experiments. Learned about how to do experiments so well. I want to learn about how to hold an online experiment easily, which is good. We'll do that during the second day, actually. How to design an experiment. About reaction time in Word, completion test, easy psychological experiment. Okay, so just a lot of people who are not specifically interested in one thing, but just more generally about learning to work with OpenSesame. I guess that's what I take away from this. I want to know how OpenSesame can improve my research. Okay, well, that is good because that is basically exactly what the workshop is about learning OpenSesame. So let's switch back to the slides. Up. And so what we're going to do today is start with this short introductory presentation. And let me tell you a little bit about the workshop schedule. So for all the 4 days. At any moment, by the way, feel free to ask questions in the chat or feel free to ask questions simply by asking something. There are 16 people, so that is a low enough number to just basically interrupt me by saying something with the microphone. That's okay. But if you want to, the chat is also fine. I'm looking at the chat right now, so I'm monitoring it. So it's a 4-day workshop. Every day will be in your time from 1 to 5. So we have 1 day part every time. And today we're going to just basically get to know the software and get started sort of with the idea of working on your own experiment. Then the second day, and there's a bit of a gap in terms of dates, which is largely due to my own schedule that I wasn't available for a while. But during the second day, we're going to focus on how to conduct an experiment online. And then during the third day, we're going to focus on how to do an eye tracking experiment. Clearly, most eye tracking experiments are actually, you cannot do them online. But what we're going to do, and that is kind of cool, is actually see how you can do a little bit of very poor quality eye tracking, even with the webcam. This is something I've been playing with, a library called webgazer.js, which I wouldn't necessarily use for serious research, but it's kind of cool to play with anyway. But we're mostly going to focus on properly lab-based eye tracking studies. And then during the last day, April 27, we're going to focus on data analysis. And in all of these days, the level will be easy unless you tell me otherwise. So basically, I will occasionally sort of ask you what kind of difficulty level you want to aim for by asking a little bit of feedback, whether it's too easy or too difficult, etc. But my starting point is that during the entire workshop, we are not or hardly going to do any coding, so no Python programming or JavaScript programming, but really focus on the graphical user interface. A little bit of an exception we will make during the data analysis day, where we will use a little bit of Python code to merge the data files, but mostly, again, use a graphical user interface, a program called JASP to do the data analysis. But if during the workshop we find that actually you want a little bit more challenge, then we can do that too. So that depends also, you have some control, the direction you want to go. And Wisnu already actually told me that most of you have some experience with OpenSesame during the, therefore I decided also during today, when I initially wanted to do only very, very basic stuff, I think that might be a little bit too boring for you then I will show also in the process a few more challenging things. And during all days, the idea is that you work on your own experiment. So if you go to the document, Wisnu already sent out this spreadsheet, right? Participant spreadsheet. In that participant spreadsheet, please indicate what kind of experiment you want to create. And Wisnu's posting that link in the chat right now again. And that will help me to sort of get an idea of the experiment that you will make. And then the idea is that at the end of every day, we have a bit of free time. And during that free time, I will sort of do the digital equivalent of sort of walking around a digital practical room, helping you work on your own experiment. And we will see how that goes. There's always an element of awkwardness of doing that with these online sessions. But basically, I will just ask everyone one at a time and sort of go in a circle, so to say, while the other people are working on their experiment. That's the format that I'm aiming for. And just to basically help you. Yeah, so that's the idea. So here's this the website. So if you go to osdoc.coxsci.nl/binus2022, you will get basically the schedule and a bit of a description of what we're going to do every day, and also importantly a link to this spreadsheet that that I ask you to fill out. So please go there. Okay. If there are no questions about the schedule or about the practicalities, then let's talk actually about what OpenSesame is. So OpenSesame is what I call a graphical experiment builder. So that means it's a graphical user interface, a point and click type of drag and drop type of software that allows you to make psychology experiments. And what kind of psychology experiments? Well, basically any kind of psychology experiment, right? So a social psychology experiment with some questions, but also a reaction time experiment, an eye tracking experiment, etc. So in a way, just to put it kind of very crudely, it is somewhere in between actually programming something and a PowerPoint slideshow, so to say. You can complement your experiment with scripting. What does that mean? Well, it means that you can embed Python code in your experiment. Python is a programming language that it is used a lot in scientific purposes, for data analysis, etc., but also for building psychology experiments. And the idea is that programming will give you a little bit of flexibility in creating your experiment, more flexibility than when you have only the graphical user interface, right? So imagine, for example, that you have a display where stimuli are completely randomly distributed, a visual search task with stimuli that are randomly distributed, have all kinds of complex properties. That would be quite impractical to make that with only the graphical user interface, and then you can use Python scripting. I'm actually curious who here has experience with Python scripting. If you do, can you post that in the chat, and I have some idea of the extent to which the audience actually has some familiarity with that. I see few people confirming in the chat that they have some experience with Python. Okay, that's good. You don't need it for this workshop, but it's still good to have. You can also include JavaScript in your experiment. So that JavaScript is a different programming language. And basically you can mix and match JavaScript and Python script in OpenSesame experiments to some extent. My recommendation would be, where if you need to run something online, and you want to use scripting, you have to use JavaScript. There's no getting around that because browsers only execute JavaScript, basically. If you run the experiment on the desktop, in principle, you can choose between JavaScript and Python. But my recommendation would then be to use Python because it offers more flexibility and is also more user-friendly, I think. But basically, there are two programming languages that you can use in OpenSesame. And if you want at some point to go into those programming languages, which is currently not the schedule, then just tell me, because then we can adjust the schedule accordingly. So OpenSesame is open source. What does it mean? It means that you can download it free of charge. I'm assuming that all of you have actually already downloaded OpenSesame and installed it on your own computers and tested that it actually works, because I don't really have time to help you sort of debugging, basically, does this work on my computer or not? So that's not so interesting, mostly for the other participants. So if you haven't already downloaded OpenSesame, go to the documentation, download it, and install it right now while I'm giving this introductory presentation. And Wisnu is kind of promoting my Python tutorials website, which is called pythontutorials.eu. Thank you. That's indeed a series of Python tutorials, not focused on OpenSesame, but just focused on general Python skills, and also Python in the context of data science, and even a little bit of deep learning. OpenSesame is cross-platform, which means that it runs on different operating systems, essentially. So Windows and Mac OS, that's what most people are using. I'm assuming also that in this audience, most people are probably using Windows, and a sort of large minority is using Mac OS, and that is my guess, based on what is usually the case. I am actually personally using Linux, so you will see me using Ubuntu Linux, but the software works the same. And you can use OpenSesame in a browser, but only, it says runtime only, because you cannot actually run the software itself in a browser. It's really a desktop application, but you can run the experiments that you create with the software in a browser, with some restrictions that we will look at during the second day. But basically, yes, you can create online experiments, but you cannot run the software in a browser. So OpenSesame fits many types of research. What do I mean? What kinds of things can you create? Well, you can create psychophysics experiments. I personally have a psychophysics background. What is psychophysics? Sort of low-level reaction time and accuracy experiments with simple visual stimuli, random dot gradings, movement stimuli, things like that. You can do neurophysiological experiments. What is that? Well, for example, EEG, if you want to call that neurophysiology, or perhaps electrophysiology, but things where you measure some kind of bodily signal, essentially. Neuroimaging, fMRI, is usually, right? So what does it mean to do neurophysiology or neuroimaging? Well, the experiments are usually just the same as a behavioral experiment, but then you need to have some kind of way to interact, to link OpenSesame, the software, with the acquisition device, right? With the fMRI scanner, or with the EEG acquisition device, things like that. So basically, it is not so much about building the experiment, but it is about knowing how to have the experiment communicate properly with the device that you want to use. And usually that is something that is very specific to the type of device that you are using, but it is virtually always possible. And actually, at the moment in Groningen, in our lab, our lab, we are basically right now setting up a sort of a combined EEG eye tracking lab, so that we can do pupillometry and EEG at the same time, a little bit like the lab that you see this little girl participating here at the bottom, with OpenSesame. Social psychology, so you can do questionnaires essentially, but also implement sort of these standard things. Think of a implicit association task, for example. Think of a social exclusion game, these kind of standard social psychology paradigms. And clinical applications. What are clinical applications? Well, imagine, for example, that you are a neuropsychologist and you want to conduct some kind of neuropsychological test. Maybe you want to do a cancellation test, which is a way to see whether someone suffers from left side neglect. Then you can implement that cancellation test, maybe implement it as an online experiment that you can run on a tablet in a browser. Then you give the tablet or the phone to the client, the patient, and in that way sort of conduct clinical testing. And eye tracking. So we will focus in the third day on eye tracking. Now, so I'm curious, actually, maybe some of you can post in the chat, I'm trying to force a little bit of interaction here. Maybe some of you can post in the chat what sort of your general field of research is, right? I know it from Wisnu a little bit. His field is very similar to mine, also eye tracking and classical experimental psychology, multimedia, multitasking, etc. But I'm also curious to hear from the rest of you what sort of your general field of research or your interest is. And pupillometry. So pupillometry is just eye tracking, right? So if you do eye tracking, you get the position of the pupil, but also the size of the pupil. Social and cognitive psychology, couple stress management, self-regulated learning, psycholinguistics. Okay, so very varied, actually. Lots of... We will actually anxiety, eating behavior, mental health. Okay, that's good to know. So I take away from this that quite a few of you have I would say, not classically, to me, classically experimental interest, but very much a clinical interest, actually. And that is also interesting, also because then you can, in terms of creating an experiment, think of something that is actually really relevant for your own field of research. And I see someone saying psycholinguistics, and during the eye tracking day, I actually was thinking of conducting a pretty classic psycholinguistic test, namely a self-paced reading task. So in terms of support, where can you get support, right? It's always important. Right now, I'm giving you this 4-day workshop, but of course, if you actually really start using the software, you will need help all the time. Employee engagement and performance appraisal. Okay, so sort of organizational psychology. All right, that's interesting. Very varied, actually. So, and where can you get this support? So the main location to find support is the documentation side. So osdoc.coxeye.nl, that is where you find very elaborate documentation. So basically the two of the tutorials that we're going to follow are just from the documentation side. Because why? Well, usually if I develop workshop materials, then I actually reuse them also as documentation. And there are the tutorials also of different difficulty levels. So if you start at the basics and then you work yourself way up with. In terms of asking questions during this workshop, of course, you can ask me questions, but after the workshop, the place to go to would be the community forum. And at the bottom, you see a screenshot of the community forum, forum.coxeye.nl. And this is actually shared with a lot of other free software, sort of free psychology software projects. JASP being the statistics software that we're going to use also on the fourth day. Pygaze, the eye tracking library. JTOS, the program that we will use for managing the online experiments. So this sounds a little bit abstract, but basically we will create the online experiment with OpenSesame. but then there will be a server that you need to sort of upload the experiment to and generate links to participants, and it stores the data, etc. And that software is called JTools that we're going to use. And basically JTools is a different software project. All of these things are different software projects, but they live on the same support forum. And the history of that is that a long time ago, by now, I think in 2010, I started the support forum only for OpenSesame. But then over time, I invited basically these other projects to use the forum as well. And it's kind of nice because that creates a community of like-minded related software projects that also share a lot of users. So now actually this has grown into quite a large forum with right now more than 9,000 members and quite a lot of daily activity. So don't hesitate to post questions there. Okay. So this was a little bit of background about OpenSesame. If there are questions about that, please post them in the chat. And if I don't see any questions, I will move on to a very brief introduction of how to use OpenSesame. So
maybe a couple of notes first.
Yeah.
So in addition to the forum that Sebastian has mentioned before, we also have 2 intern students at the lab at the moment. So Hiskia and Junior, can you open your cameras for a bit? So Hiskia and Junior are now working at the lab. So one of their tasks is to develop a series of tutorials on developing the cat dogs capybaras experiment that we will also demo. Well, Sebastian will demo it, and we might want to try building it as well in the during the workshop. But if for some reason you want to get into specific steps, then you can also check out the tutorials that they will develop. It's not going to be now, but like over time until June, there will be a complete series of tutorials.
Okay, that's super cool actually. And when you mentioned that, I was also wondering, we can also switch, of course, to a different tutorial for the second day if that generates a little bit of overlap with what you're doing now. Do you think that's a good idea? We can talk about that later.
Yeah, we can talk about that later as well. Like depend on the audience, but from my side, I want to start as slowly as possible to build the interest first.
Yeah, well, we will go very slow. Don't worry. That's good. And who are so you gave the names, but who are the 2 research assistants?
So they are undergraduate students from the side from our undergraduate programs. Do you want to introduce yourself?
Yeah.
Go ahead, Kia and Junior.
Okay, so hello, Sebastian. My name is William Junior, and I'm 4th year, final year student. So I'm now doing my thesis, and I'm also helping. We call it Mr. Wisnu, in the psychology lab, and yeah, I'm on my final year. For me personally, I'm very interested in OpenSesame because I'm in my dreams. I want to work with or in the field of neurodevelopmental disorders, and I think that will these skills in OpenSesame will help me a lot in doing research.
Thank you. Nice to meet you.
Nice to meet you too.
Hello, Mr. Sebastian. My name is Hiskia, and you can call me Kia. I'm in internship in lab psychology with Mr. Wisnu, and I'm interested in about neuro and connective things. Sorry, I'm a little bit nervous. Sorry. I'm also interested in your app, especially because it helps students about how to use experiments so well. So yeah, that's all I can say.
All right, thank you. Well, it's very nice to meet you, and actually really cool also to hear that you're working on these tutorials. So, yeah, okay. So, is that the end of the note, Wisnu?
Yeah, and also there's a plan to have our own JTools server, so that's something that I'm working on at the moment.
Okay.
For the workshop, during the workshop, we will still going to use the Mindproof. We're gonna have our online experiment hosted in Mindproof for now, but Hopefully at the end of this year, we have our own data server here at Binus so that we have more flexibility for hosting online experiments later on.
Okay, that's very cool. Yeah, so we'll look at that in the next day. But basically, the JTOL server, as I mentioned, is the server that holds the experiments. And right now, the server that we will use actually for the workshop is one that is sort of centrally organized, in part by me, called MindProbe. But basically, it is just software that can be installed on different locations. And it's also always nice if a university has a JTOL server that is basically physically located at the university, because then you have you don't have to sort of rely on someone else to keep your data safe, basically, but you just have the data physically at your own location. So that's actually a really good idea. So about using OpenSesame. So the main thing to know is that an experiment is a collection of items in OpenSesame. What does that mean? Well, items are kind of like a Lego type of thing where, all right, bye Wisnu, where the items are building blocks of the experiment. And one item does one thing. So we'll make that a bit more concrete in the future, but say, for example, you have an item that's called a sketchpad, and it presents, it is a visual stimulus display. So then you have this little building block and you insert it in your experiment where you want to present, say, a fixation dot, and another one where you want to present the target, etc., etc. You have an item called a keyboard response, and it collects a single key press. So, you present a sketchpad with the target and then a keyboard response to collect the keyboard response. You have a logger that actually writes the data to the file or to the JTOL server. You have a loop that adds a bit of structure to the experiment. Sounds a bit abstract, but we'll take a loop at that later. So basically what it does, it repeats another item while it is sort of varying the independent variables. When I say the term independent variables, I'm sort of assuming that you are familiar with this kind of basic research methodology. If not, then just don't be sort of ashamed to ask, because I know that different universities, of course, have different terminology for those kinds of things, and also have a different emphasis on research methods or more clinical things, etc. So, but I'm assuming that you're familiar, that when I say things like independent variable, dependent variable, within subject design, things like that, that you are familiar with those terms, unless I hear otherwise. A sequence is an item that basically runs a bunch of other items sequentially, so it also adds structure to an experiment, etc. Now, what does that look like? So here you have a screenshot of what is called the overview area in OpenSesame, and you see that all of each icon there is basically one item. So here you have the fixation dot that is a sketchpad that presents something. You have a keyboard response that collects a key press, a logger. You also see that there are sort of these little things that have a Python icon next to it. They're a special kind of item that is called an inline script. And that is basically how you add scripting to the experiment, which, as I said, we're probably not going to do during the workshop, but if you do it, that's how it would work. By the way, if this is very small for you to see, tell me, because then I will reduce in a bit my display resolution actually, because I don't know what kind of display you're using to look at this workshop. Items have a graphical user interface and a script, and that's something that I just want to highlight already now. We're going to take a look at that later. And this script is in a simple language called OpenSesame script, and it is not Python. So there's very often a confusion between the script that sort of defines the experiment and Python scripting, which you can use to include code. So the experiment itself is not defined in Python or JavaScript, but in this very simple language. And you see that illustrated here at the bottom. So here at the bottom, you see a sketchpad that is very simple, and it presents a visual stimulus. And the only thing that it does is say OpenSesame 3.3 lengtheform Loewenfeld. So basically it presents some text. The thing that you see at the top is the graphical user interface that shows graphically what that sketchpad does. The thing that you see at the bottom is a script. And that script corresponds 100% to the graphical user interface. And you see, actually, it's a bit small maybe for you to see, but I highlighted this text that says OpenSesame 3.3 lentiform Lumenfeld. And you see that the lentiform Lumenfeld is in the script sort of in between these italic tags. These are their HTML tags that translate to the text actually being italic. You also see that there's a few things like there is the duration is set to key press, etc. If the cool thing is that you can switch between the graphical user interface and the script. So if I would change something in the script, say I would change it to OpenSesame 3.4, you would see that reflected in the top in the user interface and the other way around. So you can go back and forth to tweaking the script and tweaking things with the graphical user interface. And that adds a lot of flexibility. And we will, especially when you want to include variables in your experiment. We will take a look at that later. So, but basically keep in mind that behind all the graphical user interface stuff that we're doing, there is a very simple textual script under the surface. Now, what about variables? How can you use variables in OpenSesame? So variables can be defined, for example, in a loop item when they are, and then you would call them usually independent variables. We will take a loop at that later, but basically you will have a spreadsheet. Where in the spreadsheet, every row of the spreadsheet corresponds to one time that another item is called, for example, one trial, or maybe one block of trials, that depends on the structure of the experiment. And every column corresponds to an independent variable. So you might have one column that is called condition, and then you have a few different conditions, right? So maybe an angry face condition and smiley face condition. And that is then you have the variable with the name condition that has the values angry face and smiley face, and it is varied between trials, and that would make it an independent variable. There are also, for example, the keyboard response will also define variables. And in that case, you would call them response variables because they're not manipulated. They're actually dependent variables, things like response time, whether you were correct or not, what kind of response you entered. They're also variables, right? So technically speaking, there's not really any difference between independent variables and dependent variables. They're both just things that have a name and a value. But conceptually, they're different because the independent variable is usually part of your experimental design and the things that you're manipulating, whereas the dependent variable is actually part of the stuff that you want to measure. Now, in OpenSesame, you can refer to these variables later, for example, in a sketchpad item, and you would do that using this notation, sort of between square brackets, the name of the variable. And you can essentially do that everywhere in the user interface. So I'll give you a few examples of how that works. And this adds considerable flexibility. So here you have a loop item that we will see in more detail later. This is a block loop, and it calls a trial sequence. So basically, every time that one cycle of this loop is called, it corresponds to one trial. So we have 8 trials. They're executed 3 times. You get a nice summary. It says, okay, trial sequence is called 24 times in random order. Why 24? Well, 3 times 8 trials is 24. And you see that there are 8 variables defined here. So we have a variable called gaze cue, left, right, left, right. So sometimes it's left, sometimes it's right, the target, the position of the target, etc. And this is how in a loop you would define your independent variables. We will take a look at this later. Now, how do you use these variables? Well, here, for example, you have a feedback thing, a screen that gives feedback, and you see that between square brackets, we are saying average underscore RT. That is a variable that is automatically maintained by OpenSesame that maintains the average response time of the participant. And in many cases, that's something that maybe you want to use to give feedback, for example. And the same with ACC, the accuracy of the participant, also automatically maintained by OpenSesame. And you can just embed these things in the text, and they will be automatically sort of parsed into the actual values when the text is shown. That is one way to use them. Another way to use variables, and these are all examples from the tutorial that we're going to do, is to use them to define run if statements. So here you have an example of a trial sequence. A trial sequence is a sequence that contains a bunch of other things that are executed in sequence. Most of these things are actually sketchpads that present visual stimuli, a keyboard response that collects a response. But then we have what is called a sampler that plays back a sound. And we want to basically use that sound to punish the participant when they're wrong. And what we do is in the run if statement, we say between square brackets, the variable correct needs to be equal. And if that to 0, and if that condition is met, it means that the participant gave an incorrect response, then the sound is played. That is one way you can use a variable.
Sebastian, just to confirm, so most of the times if you just put just one equal, that is assigned in variables, right? So if you want to check if a condition is true, then sometimes you need 2 equals.
Okay, yeah. So it's a good question, actually, really. So this is a bit of a technical point, I guess, but an important point. In many programming languages, there is a distinction between an assignment and a comparison, which in natural language, we would in both cases use an equal sign for. So say that you have the variable a, and you want to assign the value 1 to the variable a, then in most programming languages, you would say a equals 1. And then once that's executed, the variable a will have the value 1. If you want to ask whether the variable a has the value 1, that's a comparison. And in most programming languages, you would use 2 equal signs for that. So you would say a equals 1. And because conceptually, there is a distinction between assigning values to a variable and asking whether a variable has a particular value, right? In OpenSesame script, so the simple thing that you see here, there is no assignment possible. So by definition, what you're seeing here is a question: is correct equals to 1? Is correct equal to 1? And it will work with a single equals operator. It will also work with the double equals operator. They will do the same thing, basically. Does that clarify things for you, Vishnu? Yeah, but
for for consistency reasons, wouldn't it be better if we consistently say this? For comparison, just use 2 equals instead of using 1. I don't know. I'm super technical about this because
you have a point. Yeah. It's a point could be made that it is better to use 2 equal signs, even though it's not necessary, to avoid the potential confusion.
Yeah.
I'm not entirely sure. The downside of doing that is that for people who are not familiar to programming, a double equal sign is a bit weird, right? They will assume equal signs. In any case, both will work in this context, but in the context when you start programming, then the distinction becomes important. Yeah, but here, in any case, this is a comparison. Here we are not assigning this value 0 to the variable correct, but we're asking whether correct is equal to 0. Okay, so with that, I want to say let's get to work. Let's take a look actually at the schedule. Let me go. Main scene. OS doc. The Venus. Okay, so what we have for today is we're going to, for another 40 minutes, basically start with the first part of the tutorial. Then we're taking a little bit of a longer break, and then we will continue with that tutorial. And then at the end of the day, you will work on your own experiment. My suggestion will be that we actually take a mini break right now of about 5 minutes, just to get a cup of coffee and things like that, and for me to set things up. Does that sound like a good idea, Vishnu? Yeah, all right. So then I will sort of turn off my camera for a second, and then in 5 minutes I'll be back, and then we'll start with the workshop. All right. So I'll see you guys in 5 minutes, and enjoy your coffee. Hi everyone, I'm welcome. I'm back with a fresh cup of coffee. So Vishnu pointed out to me that that if I do this thing where I actually sort of merge the screen sharing with the webcam, that it becomes a little bit blurry for you if the connection is not that great. So I went back now to regular screen sharing. So also because I don't necessarily want to do the split view anymore. So what actually, what looks better basically, Vishnu? Is it a nice, does it look good in terms of presentation if I do this kind of side-by-side thing? Or is it actually better to just stick to the regular screen sharing, you think? This looks better, right? Okay, then I will stick to the regular screen sharing from now on. Okay, so what we're going to do now in this in the next 30 minutes is make a start with the beginner tutorial, the so-called gaze queuing tutorial. I know that some of you, and perhaps most of you, have already looked at this, and therefore what I will do is add a few. I will use this also sort of as a way to sort of explain the logic of OpenSesame to you, and in a way, in an opportunity for you to ask questions. At the same time, I will also add a few new things to the mix that you're probably not familiar with, just to make sure that there's not too much overlap with what you already did. Because Vishnu, can you actually tell me what did you call? I know that you had like an introductory session. What did you do there? Right, I think. Okay. Wait, sorry, the previous response was actually Raymond, not, okay. So I see someone else who participated in the demo. What did you do? Did you actually do the gaze queuing tutorial there?
He actually demoed it for us, so we haven't tried it by our own, but we see how he worked from scratch, and yeah, to make the items and to run it, and we even tried the outcome of what Vishnu demonstrate to us in OpenSesame, so we know the back end, and also we tried as a participant. That's what we have done, but we haven't get a chance to actually get hands-on with the application.
Okay, good, I got it. And in that demo, was that focused on the gaze queuing tutorial, or was there a different one?
Oh, I think I made a Postner queuing task.
Oh, so Postner, you told me that. Yeah. Okay, good. Then there actually not that much overlap. All right. So here we go. Here's what I do. I cannot see that you're actually doing that, but to make the most of the workshop, follow along. So what I will do is now show you how to start with this beginner tutorial. How can you go there? Well, you go to osdoc.coxsite.nl, just the normal website, right? And then under tutorials, you click on beginner, and that's where you should be. That is the gaze queuing tutorial. Then I will start just by walking through the steps. You follow along, but do actively follow along on your own computer. And then later, after the break, after the big break, I will sort of encourage you to go to work and complete the steps yourself while I sort of digitally walk around to help those people who get stuck. So the idea is really that you go and get hands-on with this tutorial. That's the idea. And at any moment, interrupt me with questions, because that's why I'm here. Okay, so I've started OpenSesame, right? For me, it looks like this. And now we're going to create the gaze queuing tutorial. What does the experiment, I keep switching. What does the experiment look like that we're going to create? It is conceptually actually very similar to the Posner queuing task that Vishnu showed you probably. Was it an endogenous Posner queuing task with an arrow or with a flash?
With an arrow.
With an arrow, okay, that's very similar. So, but this one is cuter because there's no arrow, but there's a face. And the face can either looks either to the right or to the left. That's it actually, it looks to the right or to the left. And the task of the participant is to indicate whether the target is an F or an H. So there is always an X, which is the distractor, and there is always either an F or an H on the other side, and the participant has to say F or H. Now, and then the manipulation is, it's very trivial, but that the face either looks at the target or it looks at the distractor. In this case, the face actually looks at the distractor. And then the classic finding is that the participants are faster when the face actually looks at the target. So in this particular example, the participants would be quite slow, actually. Now, why is that? Why does that happen? Well, the face does not predict the location of the target at all. So it's always 50-50. But the idea is that people are such social human beings that if you see a face like this, basically you cannot help but be attracted by the thing that the face looks at. And that also appears to be a very robust finding, basically. So that's the experiment that we're going to create. What kind of experiment is this? So this is, just to go back into the terminology, a fully within subject design, right? So all participants participate in all conditions, right? So all participants see the gaze into the left and to the right, etc. It's not the case that some participants are only, exposed to one face and other participants to another face. It is fully crossed in the sense that all combinations of factors occur, combinations of conditions occur. And the conditions that we have, the factors that we have, is gaze side, what the participants looks at, left or right, the target side, whether the target appears on the left or the right, and the target letter, which is F or H. In other words, it is a 2 by 2 by 2 within subject, fully crossed design, technically speaking. So let's start. Now I will move my browser out of your field of view again. And I will start with step 1, where we're going to create the main sequence of the experiment. So you click on the default template, and that does essentially nothing. It just loads the template that you see here. The idea is that there is a default template, and there is also an extended template, and the extended template actually already has a lot of the logic in it that is useful for creating an experiment. Oh yes, okay. Vishnu is interrupting with something with the cool, because you got a talk by Alan Kingstone, of course, and he indeed is the originator of this gaze queuing thing. And that is not a coincidence. This is all connected, let's say, because I actually went to Alan Kingstone's lab for my master thesis, and that's why I picked up this idea. Yeah, so we start. If you click on the default template, then you have this very basic thing. If you click on the extended template, you get a more elaborate, basically, template for starting an experiment. This, in principle, would be more useful for what we're going to do. But because I think it is important that we see basically every step of the way how we implement an experiment, I suggest that we say new default template and we start completely from scratch. That's what we're going to do. All right. And what we're going to do first of all, is sort of start from the top down with the basic structure of the experiment. And right now we have at the very top level, we have an item that is called experiment. And it contains, that is sort of the main container of everything in the experiment. Right now, the experiment just is a getting started notepad. So it has a little bit of explanatory text in it and a sketchpad that says welcome. Well, it doesn't actually say welcome, it's called welcome. And it has the text OpenSesame 3.3. Lentiform Leuenfeld in it. This means that if I would run this, Oh, that's sent. You're seeing this, I hope. That basically, this is the experiment that we have in the default templates, just a black screen with this text. And if I press a key, then the experiment is done. That's all there is to it. Clearly, that's not what we want. So we're going to completely start from scratch. I'm going to click on these two elements, say permanently delete, yes. Right click, permanently delete, yes. And now we have a completely empty experiment. I'm also, because I think it's always nice to give things, to organize things well and give things informative names. I'm also going to click on the thing called New Experiment. If I do that, you go to what I call the General Properties tab that just has some basic configuration of the experiment in it, such as the foreground, the background, etc. And I'm going to give it a good name, and I'm going to say, okay, Venus Day 1 tutorial. You can also indicate a few things here. You have, for example, the foreground, the background. So right now, by default, the foreground is white and the background is black. Actually, I happen to know that the stimuli that we're going to use have a white background. So it makes sense to actually flip this around already. So let's say, okay, foreground is black, background is white. You can indicate colors in many different ways, by the way. I can say use the color picker and select something, and then you get what is called a hexadecimal color notation. For those of you who know HTML, that's probably familiar. It's not very user-friendly, but basically it is a way to say how much red, how much green, and how much blue there is. I can also give an intensity. If I say 255, it is white. If I say 0, it is black. If I say 128, it's in the middle, so it's kind of gray. I can also say I want to have hue, saturation, luminance color space. And then I say the hue should be 0 degrees on the color circle. The saturation should be 100%. And the luminance should be 50%. Something like that. There are many different ways in which you can indicate colors in OpenSesame. They're documented on the documentation side. But for our purpose, let's just say black. Okay. And then Wisnu says the object will be permanently deleted. Yeah, so there's what I did right now is if I right click and say permanently delete, your object will just go poof. If I right click and say delete, or if I just press the delete button, it will actually be moved to the trash can, basically the unused items bin. Now, if I click on the experiment, our experiment does nothing now. It's completely empty. So if I would run it, it would finish immediately. What we want to have is basically at the start of the experiment, we want to have an instruction screen. Now, there are many ways to give instructions. What I'm going to do now is do something that in a way I don't even like that much, but I'm going to do it to keep things short. I pick from the form, a form text display. I click on it and I drag it into the experiment thing. I can drag it here or I can drag it here. Doesn't matter. Up, and I drop it. And now I have a new item that is called new _ form text display. I can say right click rename. I can press F2 or I can click here. It's all the same thing. And I give it a new name and I call it instructions. And right now, basically this thing will correspond to sort of a text, a form basically, with a button that says okay, a title that says title, and a text that says your message. And here we are going to add instructions. We can do that later to actually make the instructions nice. But for now, we have a placeholder for where the instructions are going to go. I hope that's clear. After the instructions, we're going to have a practice phase because we want to explain to the participants how the experiment works and gives them a few trials to actually try it out. For that, I'm going to use another item, this one. It's called a loop item. We've already seen it briefly in the introduction. I'm going to pick it up and drop it here. It's called new loop by default. And I'm going to click on this and say practice loop. And what is the practice loop going to be? Well, it is going to be like a container that contains practice blocks of trials. We will see this full structure unfold later. But a loop by itself is something that doesn't do anything. It needs content. It needs another item to run. So what I'm going to do is pick up a sequence, click on it, drop it onto the practice loop. And then it will ask, do you want to actually insert it into the loop, or do you want to insert it after the loop? Right, so I select insert into practice loop. And if I do that, you will see that the new sequence is sort of nested in the practice loop. If I would have selected after the loop, basically the practice loop would have stayed empty and there would have been an item after it. What I do, I'm going to rename this and call it block sequence. And now what is the logic here? You will very often in OpenSesame see this kind of combination where you have a loop and inside the loop there's a sequence. We will see this multiple times actually. In this particular case, it means that the block sequence, when we are done, currently it does not, but at the moment when we are done, it will correspond to a block of trials. So not one individual trial, but a block of trials with a break afterwards and sort of stuff in it so that there are multiple trials, etc. All of that will go into this block sequence, which is currently empty. Then the block sequence itself is nested in a practice loop, and that would allow us to execute this block of trials multiple times if we would want to. And for the practice loop, we probably don't even want to. We just want to have one block of practice trials. But later during the actual experiment, we do actually want to have multiple blocks of trials. Now, after the practice loop, I'm going to insert another form text display. I'm going to drop it onto the practice loop and now say insert after. Well, and you see the difference, right? Now it actually follows the practice loop rather than go into it. By the way, if right now I know that my display resolution, I reduced it already a little bit, but if this is very small for you to see, or if the connection is a bit choppy because it's still a high resolution, but please post it in the chat and then I will downgrade my resolution even further so that everything becomes a bit bigger for you. And if it is fine, then it's fine. It's clear. Okay, good. So the new form text display, I'm going to change it and I'm going to call it end of practice. And here there's just going to be some kind of text that tells the participant, oh, you're done practicing now. We're going to start with the real deal. What is the real deal? Well, it's another loop. So I'm going to pick up another loop, drop it in here. Up, have a new loop. I see so someone says my OpenSesame is sometimes lagging, and I assume that you then mean the software, not the presentation. Yeah, OpenSesame is quite a heavy application, that's true. And I think at the same time, you're also doing Zoom now, of course, by definition. And Zoom is also a really heavy application, actually even much more so than OpenSesame. So I can imagine that your laptop may be struggling.
Maybe just,
okay.
Sebastian, just to check out, like, does everyone following okay so far? Is like any problems like dragging, dropping, and so on? Just give us a thumbs up.
Exactly. Yeah, that's a good point, actually, really. That's a good. So if things are okay, give a thumbs up.
Yeah.
Okay, maybe can you slow down for a minute? So because I'm catching up with the lagging, so can you give like 1 minute?
Absolutely. Yes. And I will use that minute. Then I will go really slowly, and I will give you time to catch up, because you will keep seeing this for a little bit. Also, if you get lost at some point, right? That is okay. And then you can refer back. In this particular case, what we are doing is we are creating figure 5 from the beginner tutorial. So say that at some point I'm going to click away from here, then you can always go back to the beginner tutorial, look at figure 5, and that's where you should be, basically. So I will continue explaining a bit slowly, not too slowly, because I also don't want to make it boring for everyone else, of course. So here after, we have the new loop. This is I'm going to rename this to experimental loop. And this is where basically our the experimental phase of the experiment is going to start. Exactly. Thanks, Vishnu. That's the link in the chat to the tutorial. And right now we are at figure 5. Now, the experimental loop is going to again consist of blocks of trials. Now you might be inclined to say, okay, I'm going to have another sequence in here, and I call it, say, block sequence 2 or something. But that's not good practice, because what we have now is one block sequence in the practice loop and a block sequence in the experimental loop, but they should be the same, because our experiment is basically, the practice phase is going to be identical to the rest of the experiment. It's just for practice, but other than that, it's the same. So we actually don't want to duplicate everything. Now, and in order to avoid duplication, OpenSesame has the concept of linked copies. Now, so what I'm going to do is actually right-click on this, say permanently delete the block sequence 2. And then here in block sequence, I'm going to right-click on it and say copy linked. Control-Shift-C. If I say that, copy linked, I copy it. And then on the experimental loop, I right-click and I say paste. And I say insert into the experimental loop. Then we have something, bam, that looks very similar to what we had before, but it is crucially different because we now have the exact same block sequence occurring in both the practice loop and the experimental loop. And the nice thing of this is that when later we are going to sort of give content to the block sequence, this content will apply both to the practice phase and the experimental phase of our experiment. I hope that's kind of clear. And this is in general a very important thing to know. So in terms of development style, well, you always want to avoid as much duplication as possible. And this means, practically speaking, that you will want to use linked copies whenever this is possible. So reuse linked copies of sketchpads if you want to present the same thing in a slightly different context, etc., etc. Reuse the same logger when you want to log, right? So whenever it is remotely possible, use linked copies rather than sort of clone things as separate entities. I hope that is kind of clear. And this is a simple example of that. Now, and then after the experimental loop, which now is still sort of empty, right? We want to say goodbye to the participant. And for that, I'm going to use another text display. I'm going to drop it on the experimental loop and say insert after. And then I'm saying, okay, end of experiment. Well, and I'm going to save now. At this point, it's also a good moment to save, especially because things may crash and blah, blah, blah. So I'm going to say Control S or save. I'm going to save this in my downloads folder and save it as Venus Day 1 tutorial. Up, just to be kind of on the safe side. Okay, so what we've done now is from the top down, we've created the overarching structure of the experiment. And the structure is such that we start with instructions. Then we give the participant one block of trials to practice. Then we have a message to say you're done with practice. And then we're going to give the participant multiple blocks of trials for the actual experiment. And then when the experiment is done, we say goodbye. We could have done this in any number of ways, but this is how we chose to do it in this case. Okay.
So Sebastian, just for a bit, maybe changing the resolution would be a good idea, because
yeah, it is a bit small.
So, yeah, because some of the participants, they're using a laptop, small ones to view, view the slides.
That's a good point then. Okay, I'm going to stop sharing. Up. Share the screen. Bum. All right. This better?
I'm asking, is it better now? Thumbs up, something?
Yeah, give a thumbs up if you can see, follow it well, and also if you're following along. And if you think it goes too slowly, also don't hesitate to tell me, yeah? Because this is, for me, always a balancing act between not losing people and not boring people to death either. Okay, what we're going to do now is actually zoom in on the block sequence. So the block sequence is what will contain in our experiment a block of trials. So remember, we're going from the top down, right? So you may be inclined to initially think about the trial, what the trial should look like, but actually that's the very last thing that we're going to do. Right now, we're actually going from the top down. So we should ask ourselves, what does a block of trials look like? And we're now working on figure 6 of the tutorial. Now, a block of trials basically consists, you could say, of 3 separate things. The main thing is that the block of trials actually should contain a block of trials. So it should contain multiple trials. When something should contain multiple things in OpenSesame, that basically means you need a loop. So I'm going to pick up another loop and I'm going to drag it into the block sequence, drop it, and I will call it block loop. And now you see the sweetness of using linked copies, right? Because I dropped it into the block sequence and it appeared at 2 locations. Why? Well, because we are working with one block sequence and it just simply occurs at 2 locations in our experiment, under practice loop and under experimental loop. And they are identical, so everything that we change in the one will change in the other. Inside the block loop, we want to have a trial because the block loop corresponds to one block of trials and the sequence that's inside the block loop is going to be a trial sequence. So now we have this kind of deep hierarchy, right? We have a trial sequence. This will correspond to one, stimulus presentation, keyboard response, etc. We're going to do that later. This trial sequence will be repeated multiple times by the block loop. This will be one block of trials. One block of trials itself is part of a sequence that can be repeated multiple times by the experimental loop. Now, what is the reason of actually having this sort of double nested hierarchy? Well, we want to actually be able to, after each block of trials, give the participants some feedback on their performance. So inside the block sequence, we have a feedback item. I click on this. I drag it onto the block loop, say after, and I call this just feedback, or call it block feedback, whatever you want to call it. So this means that one block of trials will consist of a block of trials followed by feedback to let the participant know how they're doing. That's the idea. At the start of the block, it is good practice actually to reset the feedback variables. I will do this and then I will explain what it means. So there is an item that's a little bit tucked away from me because I have a low resolution now. That's called the reset feedback item. It has this kind of resetty logo. I pick it up and I drop it to the top of the block sequence. And I rename it. I call it reset feedback. Now, what is the logic here? Inside the block sequence, right? So if I click on block sequence, you see you have sort of a zoom, but it's exactly the same, right? This, what you're seeing here, is the same as what you're seeing here. Inside the block sequence, we start by resetting the feedback variables. This refers to a set of variables that OpenSesame maintains automatically. Things like ACC, for the accuracy, average response time for your average response time. And these variables tend to accumulate over time, right? They're sort of running averages, so to say. Now, in many cases, you want to give participants feedback on what they actually did in the last block. And you don't necessarily want to give them feedback on what they did throughout the entire experiment up until that point. And then the reset feedback item comes in handy because it resets those variables so that basically you start accumulating feedback from that moment onwards. The block feedback item That is the item that will, if I click on it now, you see it's just an empty screen, but later it will contain a little bit of feedback to let the participants know how they are doing. Okay. Let me know if you're still with me by raising your thumbs.
So some of you seems to, so some people asking me where the reset feedback item again. So you need to press the arrow at the bottom left on the screen first.
Yeah, that's a good. So this item toolbar, there are lots of items and sometimes they don't fit on the screen. Then if you click on this double arrow, it sort of unfolds and you will see the rest. That's the idea. Another way to add items is if you click on the block sequence, you have this plus button at the bottom. If you click on it, you can also add items. So there are different ways to accomplish the same thing in OpenSesame. If I say append new item, and I say, whatever, inline script, bam, then it will also appear. There's no difference between doing that and dragging a new inline script into it delete it again. Okay. All right. Yeah, okay. So a trial, Vishnu is saying a trial is something that you want to show participants over and over again with something that systematically changes. Yeah, so these are the kinds of things that to me, they're very obvious, but that's because I have a cognitive psychology background. And I know that for a lot of people, an experiment means something different. So if you have a questionnaire, basically, of course, you don't really have the concept of a trial. You just have a bunch of questions. Or well, you have a bunch of questions. But in the kinds of experiments that we have here and that they are very often made in OpenSesame, then basically, indeed, we present stimuli that are very similar over and over again, collect lots and lots of responses, and then at the end of the day, we average them. And basically, the combination of one stimulus presentation and one response collection, generally speaking, is called trial. And that is the logic of these general trial-based cognitive psychology experiments. If you have questions about these things, interrupt me at any time, right? Okay, so the next thing that we're going to do is fill the block loop with independent variables. So now we're going to step 3, which is figure 7 and figure 8 from the experiment. So I'm going to click on the block loop. And now we have a table, and the table is empty at this moment. So what does this table reflect? Well, each row in this table reflects one time that the trial sequence is called. Now, say that I say, okay, I just as a, say, dummy condition, just want to illustrate dummy condition A and B. What does this mean? It means that we have to find a variable, dummy condition. And when we're calling trial sequence once, it will have the value A. And then we call the trial sequence again, and we'll have the value B. The order is random. So maybe we will actually call trial sequence first with the value B and only then with the value A. But that's what it means, basically. So the rows are subsequent individual calls of, in this case, trial sequence, right? The item to run. And the columns are variables that are defined. And you can also define multiple variables at the same time. Now, in our case, remember from what I said in the beginning, we actually have 3 very independent variables, 3 factors: the gaze cue, whether the face will look at the left or the right, where the target will appear on the left or the right, and whether the target is an F or an H. So what so those are only 6 combinations, right? So we would be able to basically type all 6 of them. No, those are 8 combinations, sorry, 2 by 2 by 2. We would be able to actually enter all of them here in the table. That's not really a problem. But what we could also do is use the full factorial design wizard. And I'm just going to show that because it's kind of convenient, especially if you have designs that have many more factors than only than our 2 by 2 by 2. So I'm going to click on that. And now we have another spreadsheet. And the logic of this new spreadsheet is that we define our design, so to say. So each column now in this spreadsheet will be one factor, one variable that we want to vary. The gaze Q is 1. And it will be left or it will be right. Oh. Note that I'm using an underscore because these factors, they can consist of letters or numbers or underscores, but not spaces or other characters. Our other factor is target position. Target position can be also left or right. I'm actually not going to specify left or right, but what I'm going to do is specify the coordinates in pixel units, -300 and 300, because that will be convenient later in the experiment. But it basically means left and right. So the x coordinate 0 is the center of the screen, -300 is 300 pixels to the left, and +300 is 300 pixels to the right. And our third factor is target letter, and it is an F or an H. Now, if I click now OK, OpenSesame will automatically create all possible combinations of this. So I click OK. Up. And now you see that basically it generated this full factorial design, right? And what is a full factorial design? It means that every possible combination of these factors occurs. So left, F, -300, blah, 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 right? You have 8 rows. And that brings us to the end, to basically figure 8 almost. We can do a few more things actually to make our experiment easier. So, and what are those things? Well, say what we are actually going to be interested in during the analysis is whether the face was actually looking at the target or not. That information is already in this table, right? Because if the gaze is left and the target position is -300, then yes, that's the case. If it is right and -300, that's not the case. So, but it might also be convenient for us to actually already code that here. So what we can do is say congruency, and we say, well, it is congruent here, and it is incongruent here. I can copy paste that. Here it is actually incongruent and congruent. So I hope you're seeing the logic here. What I'm doing is basically just recoding the relationship between the gaze Q and the target pos. If they're both left, it is congruent. If they're both right, it's also congruent. If one is left and the other is right, then it's incongruent. That's everything. And this is not necessary to do this, but it might be convenient for the purpose of data analysis later. In the same way, I am going to say, okay, correct response. Here I'm going to tell the software what the key is that the participant is supposed to press in response to the target. So the target can be an F or an H, right? And the participant needs to press a different response in response to both. You can make any kind of reasonable decision here. In the tutorial, I decided that the F corresponds to pressing the Z key and the H corresponds to pressing the M key. Why? Well, because on a QWERTY-like keyboard layout, the Z is a little bit on the left, so you can have your left hand, and the M is a little bit on the right, and you can use your right hand. That's the idea. So basically, correct response is again just recoding the target letter. And the correct underscore response is kind of a magical variable for OpenSesame because it will be automatically used by the keyboard response to determine whether your response was correct or not. Right? OpenSesame cannot magically know which key is correct. You need to tell it. And the way you tell it is by defining this correct underscore response variable. So it needs to have exactly this name, correct underscore response. Now, then the final thing that we want to do is also say where the distractor is going to appear. And the distractor is the X. And I'm going to say dist pulse. Wherever the target is on the left, the distractor should be on the right. Right? So whenever the target is minus 300, the distractor should be 300. And whenever the target is minus 300, the distractor should be 300. I think I said the same thing twice now, but you understand what I mean. Okay. All right. This brings us at basically the end of figure 8. I suggest now that we follow the tutorial and take a slightly longer break, also for my sake, to relax a little bit until my 10 o'clock, so your 2 o'clock, I think. Is it, no, your 3 o'clock. Yeah, it is
half past 2, yeah?
It is half past, okay. And then we will pick up. And what I would like to ask you now, okay, let me actually do one. What I would like you to tell me in the chat, all of you, is whether you prefer to kind of keep going centrally at this point, or whether you prefer to go and from step 4 onwards to go in work on this individually. Either way is fine with me. But sort of if you feel like, okay, I really need some proper guidance and explanation here, one every step of the way, then we keep going centrally. And if you feel, well, this is a bit slow, I want to do this at my own pace and move a bit faster, then we will do it sort of, you work by yourself on the tutorial and I will be available for questions. Either of these is fine with me. So tell me in the chat what you prefer. And then we pick this up at your 3 p.m. And then we're going to do whatever you prefer, basically.
Yeah. So another alternative, if that's okay with you, Sebastian, is to break participants into different breakout rooms. So in one breakout room will be a group of people who wants to do everything by their own, and another breakout room are the ones who need more guidance. If that's also
good.
Okay.
And then we do that. I sort of do the breakout room where I explain everything one step at a time, and you do the breakout room where people work by themselves.
Yeah, that's okay with me. If
That's a very
okay
good
with
idea.
the participants. So after the break, we will have 2 breakout rooms. Well, one central, the central where Sebastian will. Wait, do you want to go into the ones that you guide participants, or the ones who?
Let me do the central one. Then I can provide some background information, etc.
Yeah. So if you want to stay with Sebastian and get a step-by-step guidance, you can stay in the main room, or you can go to the breakout room to do the exercise yourself. That's if that's more helpful. And then I'll be in the breakout room.
That's an excellent idea. Yeah. All right. Let's take another coffee, bathroom break, etc. And then we'll see each other at 3. And then it's up to you to decide which room you want to join. So, all right. See you guys in a bit. Work by yourself. Oh yeah, it's record. If you just want to work by yourself, more or less without guidance, go to the own pace, go to the own pace breakout room. If you need a little bit of help because you want to catch up, go to the catching up breakout room, and that is primarily where Wisnu will be to help you. Is that a good summary, Wisnu? I'm assuming that he means.
Yeah. So I'm okay. The one thing that I'm not sure of is that, so I'm recording this centrally, I assume, and I'm the host. So I'm not sure if I move to the breakout room, the recording will just follow me or just stay in the main room. Does anyone here know about that? Otherwise, I'll just make Sebastian the host.
I think I think I can also control the recording. So I think actually if you leave, it will just keep recording. Let's assume that.
Yeah. Okay. So then I'll move to the catching up room, and then you can find it there if you need.
Okay. Then we are going to pick up where we left off. All right. So what we did, basically, we are now at step 4. Let me remove this sketchpad here. Oh, yes. What we did was fill out, right, give content to the block sequence. And now what we're going to do is gradually work our way even further down what we did actually last was define the independent variables in a block loop. And what we're actually now going to do progressively is work our way even further down to the trial sequence here. And one thing that we need to do in order to prepare ourselves essentially for presenting the stimuli is actually get the stimuli. Now, and here OpenSesame has a very convenient concept called the file pool. So if you're in OpenSesame, you click in the toolbar on this sort of folder icon here. Then it opens an additional panel or an additional doc widget, as it is called, that is empty right now. But what this contains, it is basically a folder that can contain files. And those files are bundled with your experiment. And the main purpose of the file pool is to put files in there that serve as stimuli. And then you don't have to actually give, if you want to share the experiment with someone else, you don't have to give them the experiment file plus a zip file with all kinds of stimuli, etc. It is all encapsulated in the OpenSesame file. That's the idea. So the file pool contains stimuli, usually. It can contain anything, but usually it contains stimuli. Now, what are the stimuli that we want to have in the file pool? Well, they are the stimuli of the face, basically, and the sound that we're going to play back for the incorrect. Oh, that beeping that you hear, that's my coffee machine. So if you go to the tutorial site, then under step 4, you see links to the 4 stimuli that we need: gaze neutral, gaze left, gaze right, incorrect. And the goal now is just to download them, right? So right click, save as. Up. How this works depends, of course, a little bit on your save link as. Save link as. All right. So now I've downloaded all these 4 files. They're in my downloads folder. And now I switch back to OpenSesame. And here in the file pool, there are a few ways in which you can add files. You can basically just drag them in there from the Windows Explorer or the macOS Finder or whatever kind of software you're using. But you can also click on the plus. And then I go to my downloads folder and I just select the things that I want to add. And I say open. And then pop, they will actually appear in the file pool right there. And now we are basically at the end of figure 9. So we've added these 4 files to the file pool. Now, if I now save the OpenSesame file, the file itself will actually contain these four stimuli. So you never will need to add them separately again. This is super convenient. You do need to take a little bit care when you have an extremely large number of stimuli or when they're really big. Because say, for example, that you would do this, but the 4 stimuli would be 4 video files of an hour or something like that, then the experiment would still actually include them. But it would be extremely slow because it would basically have in the OpenSesame file these massive stimulus files, and that just makes everything really slow. So and the bottom line is just use the file pool to include files that are not so big, essentially. All right. I'm assuming that we're done with, so now we're all at figure 9. If not, ask me a question in the chat or raise your hand and then I will help you out. If I don't hear anything, then we're now going to move on to step 5, where we're actually going to fill the trial sequence with the items that we want to add to our experiment. So here I'm going to click again on the file pool. Up, it will be hidden. The files will still be there, but you don't see it anymore. And now in the trial sequence, we're going to focus on sort of adding the items that we want to have in the experiment. Now, what are the items that we want to have? So in a trial-based experiment, very often you start with a fixation dot, which is just a dot in the center of the screen. And we want to add, and that gives the participant something to look at, right? And then we can be reasonably confident that when we present the gaze cue, the face, that the participant is actually looking at that. So what kind of stimulus do we use for that? Well, let's use a sketchpad, the main stimulus to present visual stimuli. So I pick up a sketchpad and I drag it into the trial sequence. I drop it. And just so that I know what this particular sketchpad does, I double click on it to rename it, and I call it fixation dot. I'm not actually going to add content to it yet. I'm just going to say, here's a sketchpad, and later I will turn this into a fixation dot. Now, after the fixation dot, we will present a neutral gaze cue, which is the face that actually looks straight at you, right? So actually, let's go, just so that you have some idea. If I say open, this is the neutral gaze cue. This is the right gaze cue. This is the left gaze cue. So, and what we're going to do, every trial starts with the gaze cue, basically the neutral gaze cue, and then the eyes will go either to the left or to the right. That's it, basically. So for the neutral gaze cue, we pick up another sketchpad and simply drag it after the fixation dot, and I rename it to neutral gaze. After this neutral gaze cue, the actual gaze cue is going to appear. And that is that is yet another sketchpad. And I pick it up, drop it, and I call this gaze cue. So the things that I'm doing now, I'm basically defining the events that occur in a single trial, right? That's the level that we are now. We're defining the trial sequence. Now, after the gaze cue, we actually want to present the target. So I pick up another sketchpad, drop, and I call it target. And after the target, now it is time for the participant to respond. How is the participant going to respond? Well, by pressing a key. So the thing that we're going to use is the keyboard response, this item. So I pick it up and I drop it. And I just call it keyboard response. After the keyboard response, if the participant makes a mistake, we're going to present the sound. And to present the sound, we have the sampler. So I pick up the sampler and I drop it, bam. And I call it incorrect sound, because it will only be actually played if the participant makes a mistake. And now this is a moment to kind of, you see that we have a run if, this column with run if conditions. These run if conditions determine whether a particular item is actually run. Now, for most of the items, this is always, because we always want to have a fixation dot and a gaze cue, etc., etc. But for the incorrect sound item, it is different, because we only want to present that if the participant makes a mistake. So how do we do that? Well, we've already seen it actually during the introductory presentation. So I'm going to double click on this and I'm going to say correct equals 0. And remember from the discussion that we had, this single equal sign in the context of the simple OpenSesame script means a comparison. So we're saying if the variable with the name correct has the value 0, only then play the incorrect sound. That's what we're saying. Wow. Now, and then afterwards, very important, we actually want to log our data. So I pick up the logger, pick it up, drop it into the experiment, and I call it logger. Now, and you might think that OpenSesame sort of automatically writes things to file, but it doesn't. You need to actually explicitly invoke a logging action, and that is done by the logger item. And the kind of log file that OpenSesame will create is a comma-separated values, a CSV file, which is basically just a spreadsheet. And every row of the spreadsheet will correspond to one time that the logger is called. So every trial, usually one trial. Strictly speaking, it corresponds to one call of execution of a logger item, but in virtually all experiments, that's the same as one trial. And then the columns in the experiment will correspond to all the variables that exist. And in the last day, day 4, we're going to take a look at how we can actually work with that data. But for now, it is mainly important to log it. Okay, so now we're at the end of figure 10 from the step-by-step tutorial. So are you all still with me? Raise your thumb if you're still with me, and ask a question if something is unclear.
Yeah, how about if I want to put sound for the correct response?
Sorry, I didn't catch the question. How about if you want to do what for the correct response?
To put a sound for the correct response.
Oh, so you want to play both the sound for the correct and the sound for the incorrect response, basically.
Yeah.
Yeah. Now you could do that too. Then we would add another. Let me say another sampler. I would call it correct sound, and I would say correct equals 1. So basically, the logic is that OpenSesame automatically creates a variable that is called correct, and it will be 1 if the actual response that participants give matches the correct underscore response variable that we ourselves have defined here in the loop. So that is basically the reference response, you could say, the expected response. If that response is actually given, the variable correct will be 1, otherwise it will be 0. If there is no correct response defined, correct will be NA for not applicable, basically.
So the comment is always correct, right? Not incorrect.
Yeah, okay, so that's, yeah, so it is not indeed not the case that you might think, okay, then there is a variable incorrect, but no, it is actually, the variable is always correct, and the value of it, 0 or 1, determines whether it is correct or incorrect.
Okay, thank you.
That is the logic. Yeah. Practically speaking, I don't think it is so, it is a bit annoying to the participant to present too many sounds. So I never do that, basically. But you know what? Just for the sake of argument, let's in this particular case also present the sound. And then let me very quickly actually get a nice sound for the participants. So what would be a good sound? Get Sesame resources sounds a drip. All right. So we're going to present a drip sound if the participant is accurate. What I actually really like to do in experiments is not play any sounds at all, but present a very small green fixation dot when participants give an accurate response, correct response, and a very small red fixation dot when participants give an incorrect response. That is very visible to the participants, so it's very clear, but it is less disturbing than actually playing a sound, less annoying. So, but that's just a matter of taste, but that's what I usually do in practice. Okay, so now we're moving on to step 6. And now we're actually going to give content to the sketchpads of our trial sequence. So you're seeing now that we have a fixation dot, a neutral gaze, a gaze cue, and a target. But they don't have any content yet, right? The fixation dot is named fixation dot, but that doesn't magically make it a fixation dot. So I'm going to click on it, and now we have a very empty sketchpad. What we want to do is draw a fixation dot in the center. Now here on the left hand, so the sketchpad is basically a very simple paint-like application, right? I can draw a line, I can draw an arrow, a square, etc. I can make it filled, I can give it a nice color, blah, 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 blah. So we can, but we don't want to do that, of course. So let's remove all those things. Delete, delete. But the thing that we do want to add is a fixation dot. And here, this thing right here, that is the fixation dot element. So it's kind of built into OpenSesame. Click on it, and I move to the center, and I say, whoop, and there it is. There we have our fixation dot. Now, in terms of the content of the sketchpad, that's enough. But you also see that the sketchpad has a duration, and that duration right now is set to key press. What does that mean? Well, it means that this sketchpad is sort of shown until the participant presses a key. But that's not what we want, right? We want the fixation dot to just be presented for a certain number of certain duration and then move on. Now, what is that duration? That duration is 745. This sounds a bit strange. Let me explain it. What we want, for simply because I decided that, or maybe that was like how Alan Kingstone did it in the original paper, I don't remember. But we want to present this fixation dot for 750 milliseconds. And this value is in milliseconds, 745. Now, you have to know, to understand why I'm writing 745, it's important to kind of know how a monitor works. So monitors are refreshed periodically. They have a certain refresh rate, and that is usually 60 Hertz for most monitors. And that means that when it starts from the top left and then it goes tack, one row at a time, the pixels on the monitor are being refreshed. And that happens once every 16 milliseconds then, if it's 60 Hertz. If you present a new stimulus, that new stimulus is always presented at the onset of a new refresh cycle. So when the cursor, basically the refresh cursor is at the top. Now, and this means that you cannot present a stimulus at an arbitrary moment, right? So say that you present stimulus A, then the next stimulus you can present at the earliest 16 milliseconds later. And then the next one at the earliest, again, 16 milliseconds later, etc. If you try to present stimulus A and then wait 5 milliseconds and present stimulus B, you're asking the computer to do something that is not possible. And then what will happen is that that stimulus will only appear actually at the next possible moment, which is 16 milliseconds later. Now, why is this important? This duration, 745, is not a multiple of 16 milliseconds. So it is an impossible duration. And what will then happen is that basically the actual duration will be rounded up to the next possible duration, which is 750. The advantage of specifying a duration that is a little bit less than the intended duration is that you give the computer a little bit of room to breathe. Imagine that I would put here 750, and the computer would, for some kind of reason that is unpredictable, have a delay of 1 millisecond. Then it would be 751. And then actually you would miss it, and you would have to wait for yet another refresh cycle, and you would end up presenting it for 766 milliseconds, which is not that bad for a fixation dot, but it's not really what we wanted. So by actually specifying a duration that is slightly less than the intended duration, we have a higher chance of actually presenting the stimulus for exactly 750 milliseconds. I hope that's a bit clear. It's quite intricate. I appreciate that. If you go to the documentation side, if you find this interesting, and if you do experiments for which timing is very relevant, there is a section on timing on the documentation side that explains these things in a bit more detail. Right. Okay, so now the fixation dot is done. Okay, happy to hear that it's clear. Now we're moving on to the gaze cue, neutral gaze, sorry. So click on it. And now we want to present a picture. So what I'm going to do is click here on this image element. And then I click on the center of the screen. That's where we want the picture to appear. And then it pops up basically a dialog that allows us to select from the file pool. And what do we want to show? Well, the gaze neutral. So I select that and I say, bam, there we go. We have the same thing, that the duration is key press, and we change it to 745. Okay. All right. Then here we have to, then we move, we're done with this. And now we move to the gaze cue. So the gaze cue is very similar to the neutral cue, right? Because it is a phase. Duration, no, wait, let's leave that for a bit. So I draw an image element, click on the center of the screen. And now the question is, what do you actually need to select here? If I click gaze left, it's a bit unsatisfying because that only applies for the trials in which the gaze cue actually should point to the left. I'm going to do it anyway. So I click on select. And now we have the gaze cue that is pointing towards the left. Now, but then the question is, how do we actually make the gaze cue point in the direction that we want it to point to? What is the direction that we want it to point to? Again, well, if I click on the block loop, you see that we have this gaze cue variable that we defined that has the value left or right, basically. And if it is left, then it should look at the left. If it is right, it should look at the right. Now, there are a few ways in which we could implement that. We could add a gaze cue left item and a gaze cue right item and use a run if statement to execute one of them, more or less in the same way that we did for the incorrect and correct sound. We could draw both a gaze cue to the left and a gaze left on the same sketchpad and use the show if statements here. All of those things are possible. But what I want to do here is actually show you how you can use this by very cleverly sort of working with the script. So what I'm going to do now is click here at the top right, sorry. And then I have a few options and I select split view. And the split view shows what I already showed during the introductory presentation, that at the top we have the graphical controls and at the bottom we have a script that actually corresponds to corresponds to the graphical controls, but then in text. And this, of course, is the relevant line, the line that says draw image, gaze left, scale 1, blah, blah, blah. Let me zoom in a little bit so that you see it well. And what we can now do is actually, let's consider this thing, this command. It draws, that's fine. An image, that's fine. It is centered, that's fine. It is a file, is gaze left.png. That actually is not fine, because we don't always want to present gaze left.png. We sometimes want to present gaze right.png. What we now, and actually the only thing that is not fine is this, the left. So what we can do is actually remove this and replace it with a variable by saying between square brackets, gaze cue. What we are doing now is not literally trying to present a file that is called gaze underscore square bracket gaze cue square bracket.png, but instead this will indicate to OpenSesame that this is the name of a variable, and it will be replaced by left on trials where gaze cue variable is left, and on trials where gaze cue variable is right, it will become right. And then it will present either gaze right.png or gaze left.png. I hope that's clear. I'm going very slow here, but I hope that's clear, and that's a very crucial aspect, basically, of how OpenSesame works. Now, if I now press,
clarify something.
Absolutely.
So it means that when we name our stimulus file, we need to be mindful of this, right? So that's all. I just want to confirm.
Absolutely. Okay,
thank you.
So if I now open the file pool, you see that the files are called gaze underscore left.png and gaze underscore right.png. And the result of basically evaluating this, right? If you see what I mean, so replacing the variable by a value should map exactly onto the name of those files. And they do in our case. But if we would say this, for example, it would no longer work, because we are lacking basically an underscore that is part of the file name. So we are really referring directly to the names of files with the variable. Yes. Now, if I say apply, let's hide the file pool. Up. Oh, did I? Yeah. Oh, so so the file. I stopped my video because the file pool button is actually under stop video for. Okay. So now you see that there is a question mark in the center. That is not a mistake or anything like that. It is just that now we are using a. Oh yeah, Vishnu is posting the things in there. We are using the variables to actually specify the file name, and OpenSesame does not know anymore now which files should be presented. So it shows a question mark suggesting something is going to be shown, but I don't really know what it is because it varies from trial to trial. Now we have the key press. the duration set to keypress. And here it becomes a little bit, so the gaze queue should be, let's say, 495. So the gaze queue is not 750 milliseconds, but 500 milliseconds, just because we decided that, there's no profound reason behind that. And we're subtracting again 5 milliseconds to give the computer a little bit of room to breathe, as I just explained. All right, now we're going to the target. Bob.
Can I ask a question before we go further?
Absolutely.
In the top right, there's 0.77x. What does that mean? Because in my screen, it's kind of different. It showed 0.54.
It is how much you're zoomed in onto.
Okay.
So basically, if I put it to 1, it just doesn't quite fit in my screen again. If I click on best fitting zoom level, it zooms out a little bit so that I'm able to see the entire thing. And I can zoom out even further or zoom in a lot.
Yeah.
That's
so
all it means.
It's for our visual, not for participant or not for design. Thank you.
Absolutely. So this is just the zoom factor in the user interface. And the grid, these green lines, they're also not shown to the participant. They're just for us to be able to locate where things are and to actually have to snap sort of to locations, because usually you want to know exactly where you're showing something. Okay, now we're moving on to the target. So the target is similar in some ways to the gaze queue. So what we want, actually, we don't want the gaze queue to be replaced by the target. We want the gaze queue to stay on the screen and the target to appear along with it. Then you might say, okay, now we just present the target and then the gaze queue will stay on the screen. But that's not how OpenSesame works. Every display overrides the previous display. So if we want actually the target to be presented along with the gaze queue, we also need to draw the gaze queue to this this sketchpad, basically. So let's go to work. I click on image elements. So I'm starting to doing the same thing that I did before. Gaze left. But now I say, okay, let's assume that the distractor is going to be on the left side. How far into the periphery? Let's say 320 pixels. And then here I say X. It's a bit small. Let's make it a bit bigger, 48. So now we have a letter, the letter X on the left side. On the right, and the X is always the distractor. Now I try to do the same thing on the right side. And now it should be either an F or an H. And that depends on the variable target letter. So what we can do now very easily is simply say target letter between square brackets, indicating that it's a variable, and then it will appear there. And then when the participant sees it, of course, the participant will not actually see target letter between square brackets, but will see either an F or an H, depending on what the target letter is. Now, we're almost there, right? But again, just like before, we have a static display that does not really take our variables into account. Well, it takes the variable target letter into account, but not the position of the target, and also not the direction of the gaze cube. So we're going to do the same thing that we did before, but now in a little bit, we need to do a little bit more, right? I'm going to click here, say split view. And let's start with the image. Here we have the image, right? This line corresponds to the image. Up, zoom in a little bit. And we're going to, just like before, say, replace the left by the variable gaze cube. We've seen this, so I'm assuming you remember how this works. But now we have another line here, line 4. And line 4 actually corresponds to the letter X, right? So here you see text is X, and the X coordinate is -320. But remember that sometimes the distractor needed to be presented on the left, and sometimes the distractor needed to present it on the right. And if we go back to our block loop, Sometimes you see me actually toggling. If I do this, I'm pressing Ctrl/, and then I hide the overview area to give a little bit more space on the screen. That's all. It's the same thing as clicking here on this button. So you see in our block loop, we've defined a variable called dispulse that determines the position of the distractor, and a variable called target pulse that defines the position of the target. And those we need to use. So I'm going to the target. And then for this, the X, where is the X? This one. This is the line corresponding to the X. I replace the X coordinate by dispulse between square brackets. So you see it's the exact same trick as I did for the file name for the gaze cue, but now for the position of the X. And now the other one is the target. This line corresponds to the target. It's one line, but it's a bit long, so it wraps across multiple lines. And you see that the X coordinate here is set fixed to 320, and I replace it and I say target pulse. Now, that's it essentially. And now if I press apply, you see that both the target and the X are sort of in the center because OpenSesame doesn't know what kind of preview to give. It also gives you sort of a warning saying they're in the center, but it's not an error message. It's normal behavior because now we are defining the location of the target and the distractor and the identity of the gaze cue with variables. So OpenSesame doesn't really know how to give a visual preview anymore. That's all. Are there questions about this, about the use of variables in this context?
Can you please go back to the coding? I missed it a bit.
Yeah, maybe I went a bit fast. If you need to watch this back, if you go to the beginner tutorial and where's just below figure 11, you will see basically the code that I'm working with here. So you can refer back to that and then see the magic that I performed. I will make the script a bit bigger, but I will go over it for you just in case. So here, this was the thing where we defined the gaze cue. And the only thing that we changed is that in the file argument, the file keyword, we replaced the static text, the literal text, as computer scientists often call that. That is, just basically a text. We replaced that by a reference to a variable, gaze cue, that is defined in the block loop. For the distractor location, the distractor, which is the X, so the text is just X, we replaced the X coordinate by distractor position, by the variable dist_pulse. And maybe I should actually, now that I'm looking at this, I'm noticing that something that is obvious to me may not be obvious to everyone. So the format of these commands in OpenSesame script is that we have a bunch of commands, right? Draw a text line. And then all of these other things, they are sort of keyword value pairs. So there is an argument center, and it has the value 1, indicating that it should be centered. 0 would be not centered. There's the keyword, or the argument color has the value black, etc. And here, the keyword is the text that should be shown, and the value is just a capital X. And this X is itself a keyword corresponding to the X coordinate, the horizontal location, and its value is defined in terms of a variable dispulse. Now, and here we have another line. It's very similar to the distractor, but now we're talking about the target. So actually, the text should be target letter, and the X coordinate is target pulse. And I say, bop, apply.
Maybe
I hope that clears things up.
Sorry,
go ahead.
Sebastian. So if you share the script again. Maybe it also helps to see that there are numbers on the very left of the screen, and those numbers correspond to the lines. And each line corresponds, as Sebastian has said, correspond to something that you want to show on the screen. Yeah, every line is a command basically, and they're spread over multiple lines because otherwise it doesn't fit on the screen. Basically, that's all there is to it. All right, and as I said, if you get lost,
You can, of course, join. Wisnu asked Wisnu to go back to the catch-up room, but it may not be necessary, because if you see below figure 11, then you will actually see these scripts too in the beginner tutorial. Okay. Bon. Now, one thing that is kind of important is right now the duration of the target sketchpad is set to key press. This sounds very sensible, right? Because we do, as a matter of fact, want the participant to press a key in response to the target. But the reason that this doesn't work is that we're actually going to use a dedicated response item for that, the keyboard response item. And if we leave this set to key press, what will happen is that we have to press two keys. One key basically to satisfy this key press response, and then another key to satisfy the keyboard response. So what we need to do here is actually change the duration to 0. Sounds a bit counterintuitive, but what it means is basically we are showing the sketchpad and we advance immediately to the next item without waiting. That's what it means. And the next item is a keyboard response. So that will collect a key press. And the result of that will be show the target, collect a keyboard response. That's the idea. All right. Now, once we've done that, we're good. And then we can move to the keyboard response. If there are questions, interrupt me, right? Don't hesitate to ask. If I click on the keyboard response, you see that now there are a few things that we can define here. The correct response, we can just leave it empty. You see also the text in gray that is has some explanatory text on the right. It says leave empty to use correct response. So, and we have defined the correct response variable in the block loop, and that will be used here. The allowed responses is a semicolon separated list of responses that OpenSesame will actually react to. And say that we have, say, z semicolon m means the participant has to press the Z key or the M key, and all other keys are ignored by OpenSesame in any case. Maybe the operating system will still respond, for example, to the Windows key and things like that. But OpenSesame will only accept the Z and M key. And then we have a timeout value. Right now it's set to infinite, meaning that the keyboard response will wait infinitely until you press the key. But generally speaking, it is nice to actually give a little bit of time pressure. So if we set this to 2000, it means that if the participant doesn't respond within 2000 milliseconds, the keyboard response will time out. And the timeout will be the same as the participant pressing a key, a sort of a fake key called none with the capital N. So basically, now we have 3 possible keys that can be pressed: the Z, the M, or the non key, where the non key is not really a key that was pressed, but it is basically how a timeout is coded. And the timeout is always incorrect. No, that's not true, actually. If you set the correct response to none, then the timeout will be correct. But in our case, timeout is always incorrect. And then in principle, if you want to, you can also actually have the thing respond to a key release, but that's not what we want. And the flush pending key events, that means that we are only going to respond to newly pressed keys and not keys that were pressed a while back and had never been processed, basically. Okay, so now we're at the end of figure 12. Then the next step will be actually to configure the incorrect sampler item. And also in our case, because based on Raymond's suggestion, we also have a correct sampler item. So we're going to be a little bit more fancy than we were. But let's start with the incorrect sound. But how does this work? Super simple. There are a bunch of parameters for the sound, the volume, the panning, right, left, right, the pitch. But what we just want to do is select incorrect.ogg. OGG, by the way, is a sound format. It's just like WAV or MP3, but then different. For the correct sound, we select the drip.ogg. And now you ask, how do we know, how does OpenSesame know again whether to present the incorrect or the correct sound? Well, we did that, we defined that in the trial sequence with these run if statements, right? So that the incorrect sound is only after correct responses, incorrect responses, and the correct sound only after correct responses. Other than that, we don't really need to do anything with the sound. It's simply present the sound. Then we move on to the very final thing. And again, we don't really need to do anything. You missed the drip sound file. Yeah, well, it was not actually part of the tutorial, but it's just because to show that you can also actually present the sound after a correct response. That's the only, and the drip sound file, let me upload it myself actually, because I realize now that none of you, of course, have that. So send file up. There it is. But you can use any kind of file, of course, right? Okay. The last thing that we need to do is the logger. So the logger writes everything to file. So right now, there's this checkbox that says log all variables recommended. So we leave this on. What that means is that whatever kind of variable OpenSesame knows about, it will be in the log file. What variables does OpenSesame know about? Well, it depends on the variables that are actually created during the experiment. But we can already kind of get an idea by clicking on Show Variable Inspector. And then we have a list of variables that probably exist. And you see there are many, right? So we have all kinds of variables with the name time. What are they? Well, they correspond to timestamps when items are executed. We have some information about the sound. We have a target letter and a target pos, which we actually defined in the block loop ourselves. We have a response time, which is defined by the keyboard response. There are all kinds of variables that exist. Some of them already have a value because they're defined in the script. Some of them will get a value when we run the experiment, so it's empty. There are source items, lots of stuff. Is all of this important? No. For most cases, not much of this is actually not important, but it is still useful to log it because, you know, better safe than sorry, basically. And then afterwards, during data analysis, you can always create a clean version of your data file that only has the variables that you're interested in, but then at least you reduce the risk of suddenly finding out that something that you really wanted to know is actually not in the data. Okay.
Can I ask a question? How
Yes.
do you turn on the variable inspector? I think in mine it does not shown automatically. Do you need to click on something to show?
So there's the green button at the top. That's variable inspector. And that's the one, if I click on it, that's the one that you...
Yes. Yeah, thank you. Yeah.
And in general, so sort of here at the top, you have a bunch of things that you, right? So here, if I click this one, I toggle the visibility of the overview area. Generally, I have that open, but you can hide it if you want to have a bit more space, for example. Here, I toggle the visibility of the file pool. Here, I toggle the visibility of the variable inspector. Here, I toggle the visibility of the console or the debug window, however you want to call it. And here, if I click on this, I will actually launch a code editor that is based on OpenSesame called Rapunzel. Just to promote that a little bit, let me do that. So this is a, what can I say? It's a programming editor, basically. Close that. So here at the top, you have sort of the basic things that you want to have. All right. Okay, now we have basically finished our trial sequence. Are there questions about this?
Sorry, Sebastian, I have a question a bit backward because I just realized that I think I haven't duplicated this one. So I made the block loop, but I haven't had this one. You already have like 2 trial sequence.
And
yes. And I think I just made one. I haven't done the duplicate or something. Would you show me how to do it?
if you, so you can share your screen, I guess, or I can show you verbal. I don't know. Of course, don't know
I think
exactly
it's
what
better
you are.
to just share it on this. I allow everyone to share screen.
Yeah,
already.
exactly. Yeah, if you feel
If that's
comfortable.
okay.
I mean,
Yeah.
not if your
Yeah,
email
yeah.
is open
Yeah.
with all kinds of personal stuff, etc.
Just a moment.
Well, you can also share only the app. That's also.
Yeah,
fine.
that's true, of course. Yeah.
So this is my screen. Sorry. And
I haven't
this one,
wait, I'm still looking at, okay.
I need to close
yeah,
this.
I see.
Think. So this one, I did it like manually, all these item stuff.
Yeah.
But then I realized that you did it like, I don't know how to do it, like copy paste. So when you change this one, and then it's
So the link
automatically,
copies.
yeah. So I think I missed that part.
Can you scroll
Could
down
you
a little
show me
bit and I will
again?
explain it?
Oh, yes.
Yeah. Okay. So what you are seeing is that you, oh, no, keep sharing.
Oh, sorry. Moment. Yes.
All right. So you have created duplicates, basically. So you have in your practice loop, you have a link to an item called block sequence. And in your experimental loop, you have a link to an item called block sequence 1. So they are different.
Yeah, yeah.
And they are not linked copies of the same thing.
Yeah, yeah.
Now, the goal is to reduce duplication as much as possible. So all the parts of the experiment that are the same, that can be the same, should ideally be done with linked copies. And in our case, that already happens at the level of the block sequence. That depends, of course, on the specifics of the experiment, right? In some experiments, you will not have the same block sequence, but in our case, we do. So what you can, and in your case, you have developed a block sequence under the practice loop, and the block sequence 1 under experimental loop has not developed along with that because it's a different item.
Yeah, yeah.
Now, if you click on the experimental loop,
This one?
you see that it has under run, it has block sequence _1. Now, if you click on that, you will get a drop-down menu allowing you to select any kind of item. So you can do that. Click on block sequence 1 in the drop-down box next to run. No, not there.
No, wait.
To the right. So
this one, yeah.
There you have run and you have block sequence 1. And now instead of block sequence 1, just select the normal block sequence. So the one that's just called _block sequence.
Which one?
It's the third from the top. Yeah. And now, if you scroll down, you will see that now you actually have a full loop. Because now the sequence that is inside experimental loop is the exact same thing as the one that is inside the practice loop. And everything you change in the one, you will change in the other, and vice versa. And it is in principle, you can of course accomplish everything by duplicating it perfectly. But it is very error prone because it means that you're very likely to change things in the one thing and not in the other, and also a lot more work. So using linked copies is whenever possible the way to go.
Okay.
Right.
Okay, thank you very much.
Yeah, okay. And I think someone already suggested this in the chat. I think it's about the linked copy, and that's absolutely correct. So, okay. Share. All right, actually, so at this point, we are ready to run the experiment because part of it is done. Let's actually, before I run it, let's click on block feedback. So now we finished the trial sequence. The trial sequence is done. After a block of trials, we wanted to give a bit of feedback. So let's actually do that. And what is a good way to give feedback? I would say a good way to give feedback is just to give the participants some feedback on how well they did, because it's nice. It's just as a courtesy towards the participant. It's nice to tell them. So I can say end of block, exclamation mark to be a little bit excited. Your average response time was average underscore RT milliseconds. Your accuracy was %. Press any key to continue. Okay. Now, it's a bit small maybe. Let's make it a nice serif font. Let's say 32 pixels. Right. So, and then you ask, what is this average RT and what is this ACK variable? These are these kinds of variables that OpenSesame creates automatically based on the response items and the fact that you define the correct response, etc., etc. You can find information about that on the documentation site in the section about variables. It will give you an overview of all the variables that OpenSesame will automatically maintain, etc., etc. But the two very commonly used ones are average RT and ACK. Okay, so I think this is a very good moment to say, let's save the experiment, let's give it a run, and then after we see that it works or not, in which case we'll have to debug it, we'll take a short coffee break, and then we're going to continue with sort of taking a look at your individual experiments. But let's first see if this actually works. So a little note about running experiments. You see here at the top, you have various things that are related to running. The big green arrow is run full screen, and it runs it full screen as though you are participants basically running it full screen. So if you're in the lab and you want to collect data, that's what you would do. Here we have the run in a window, which is the same, except that now it runs in a window, but it will still ask you for a participant number and a log file. The blue is the quick run. It runs it in the window, and it basically automatically uses a default subject number, 999 actually, and a default log file, so that you don't actually have to enter those things during testing all the time. Then we have a stop button, which will become active when the experiment is running, if we want to kill it. And we have the run in browser button, which actually launches the experiment in test mode for running it online. And we will take a look at that during the second day. But what I will do now is actually, this is not yet an online experiment, although it should actually also run online. We will do both. But I'm going to just run it in a browser. Yep. Up here it appears. These are our instructions, right? But we haven't actually given them any content. Okay. Up. H. Correct. Can you hear the drip actually? I'll make a mistake. Error. Correct. I'll do 8 trials. F. Up. All right, now it's the end of the block. My average reaction time was almost spot on 1 second. That's impressive. My accuracy was 87.5. Makes sense because I made 1 mistake out of 8 trials. Press any key to continue. Well, I'm not going to finish the entire experiment. How can you actually stop the experiment? Well, the neatest way is to press escape and then say Q to quit. If the experiment is really sort of frozen and non-responsive anymore, you can also click on this kill button right here. And that will actually forcibly sort of kill the experiment. But I will say Q to quit. Bam. And then you get a nice message saying the experiment was aborted and some information. Okay, so my suggestion is, are there any questions right now? First of all?
I just wonder how can you kind of loop or to multiply the trial, because in this example we only have 8 possibilities of items, and sometimes we need more to just.
This is a very good question. So actually, this is step 11 from the tutorial. So what I was going to suggest that in your later by yourselves you can work on this. But let me already give you a hint at how this works. So if you click on the block loop, you will see that there is an option that's called repeat. Right now it is set to 1, meaning that every trial is executed once. If I set it to 2, every trial will be executed twice, and a block will suddenly consist of 16 trials. In addition, one level up, in the experimental loop, we also have a repeat option. That corresponds to the number of blocks that we have. So now, because the block loop is set, let's set the block loop to 2 here, 16 trials. In the experimental loop, this is 1. So we have 1 block of 16 trials. If I set this to 2, we have 2 blocks of 16 trials. And this is how you can sort of determine the length of the experiment, both at the level of how many trials there are in a block, and at the level of how many blocks there are. And both, of course, contribute to the overall length of the experiment. So my suggestion would then be that we're going to take a short break, again, 5 minutes or so. Then after the break, you finish by yourself finish the experiments or the rest of the tutorial from step 11 onwards. This is not very hard, basically, just kind of dotting the I's, so to say. And in the meanwhile, I will take that time to talk to all of you to sort of see what you would like, what kind of experiment you would like to develop during the rest of the workshop. And Wisnu, do you think it is convenient to use a breakout room for that, or shall we just do that centrally? Because that might also be nice, then everyone hears from everyone else what they want to do.
Yeah,
what do you think?
I would say just do it in one big room.
In one big room.
That's okay with everyone as well.
Okay, then we're going to do that. So let's take a 10-minute break. Is that okay?
Okay.
Then we resume 4:10 and pick things up. All right. So get a cup of coffee or something else, and then I will see you.
Coffee that you had earlier. Yeah.
And then I'll see you all in 10 minutes. All right. Right. Hi, welcome back, everyone. Yeah. So, as I said, the plan now is to I see that there are some people still in the catch-up room, but let's leave them there. So the plan now is that everyone just kind of continues working on the breakout room. On the beginner tutorial from step 11 or wherever you were to kind of polish the rest of the experiment. If you need a little bit of an extra challenge, let me actually, because it's a beginner tutorial, it's quite basic, of course. But here are 2 things that you can try to make it broadcast. How do I chat to? I'll post it in the chat. So what you can try is to counterbalance counterbalance the response mapping based on the participant number. If you need a bit more challenge, right? So what does it mean to counterbalance? It means that basically right now, all the participants are pressing the Z for the F and the M for the H. But the point could be made that it's nice for actually half the participants to do it the other way around, right? That they press the Z for the H and the M for the F. Now, and to do that, you can use the subject number. So the subject number can be even or odd. And then you can define basically the response that participants should give based on the participant number. This is a moderately advanced thing that requires some knowledge of how OpenSesame works. So don't expect to be able to